everyone, I am Felbert saladaga discussing to you the ellipse. This is one of the four basic types of conic section. So now let us start with the clarification of the word ellipse. So from the word ellipse itself, it is obtained as the intersection of a cone with inclined plane. At the same time, the word ellipse comes from the word commission, which was given by Apollonius of Perga by his conics, that emphasizing the connection of a curve with the application of area. And analytically, in mathematics, ellipse is the set of all points in a plane that the sum of cos distances from the two fixed points, which is the f1 and the f2, is constant. So our f1 and f2 here is called the foci, the plural form of focus. At the same time, ellipse has two perpendicular axes, the minor axis and the major axis. So this is our minor axis and this is our major axis. Apart from that, we have also the vertex. So this is our vertex 1 and this is our vertex 2. So when we say vertex, those are the points that is process its focal axis. And lastly, we have the eccentricity. So the eccentricity of a curve tells the amount of roundness of a curve, or shall we say the shape of an ellipse, how elongated it is represented by its eccentricity. And also, always remember that the eccentricity of the parabola is 1, while the eccentricity of the ellipse is greater than 0 but less than 1. And don't forget to remember that the eccentricity closest to 0, the eccentricity tends towards, the ellipse tends towards being circular, whereas the eccentricity closest to 1, the ellipse is elongated.
So we have the center of the origin, which is 0 and 0. So in order to get the most reliable way of solving the equation, we have 7 ways to follow. So first, we are going to find our foci and our vertices. So since our foci was already given, which is positive and negative for 0, so our focus 1 will be positive 4 and 0. Then our focus 2 will be negative 4 and 0. The same thing, our vertices was already given, which is positive and negative 5, 0. So our vertex 1 will be positive 5 and 0. Then our vertex 2 will be negative 5, 0. Then let us find the value of our C and the value of our A. So that is the step 2. So C is equal to 4. So since C is the distances from the center to its focus, or shall we say to its foci, so squaring the 4, 4 times 4 equals 16. Then the same thing, our A is 5, which is A is the distances from the center to its vertices, so is squaring. So the same thing, our A is equal to 5. So since A is the distances from the center, so the same thing, A is equal to 5. So since A is the distances from the focal point to its vertices, so square the 5. So 5 times 5, it would be 25. So since we have already our C, the value of our C and the value of our A, and now in our step 3, so our step 3 is to find our major axis and minor axis. So let us find first our major axis with the given formula 2A. So since the value of our A is 5, so it will be 2 times 5. So 2 times 5 is equal to 10. So we have now already our major axis, which is 10. So let us proceed to our minor axis. So minor axis with the given formula 2B. So since we don't have yet the value of RB, or shall we say RB is unknown, so we are going to find first the value of RB by using the Pythagorean theorem. So by the given formula, C squared is equal to E squared minus B squared, then transpose B squared equal to E squared minus C squared. So since the value of our E squared here is 25, and then our C squared is 16. So 25 minus 16 is 9. 9. So B squared equals 9. So taking the square root in order to eliminate the squared. So square root of B squared, it would be B equal to square root of 9 is 3. So we have already a value of our B, which is 3. So we continue solving our minor axis. So our minor axis, it would be 2. Since our B is 3, so 2 times 3 is equal to 6. So our minor axis is 6. Next, we need to find the endpoints of our minor axis. Minor axis, by the given formula, 0, positive, negative B. So since our B here is 3, so it would be 0, positive, 3. Since the value of our B is 3, so it would be 0 and positive 3, then 0, negative 3. So our minor axis is 0 and positive 3 and 0, negative 3. So next, we need to find our latus rectum. By the given formula, LR equals to 2B squared over 2A. So we need to find our latus rectum by the given formula. LR equals 2B squared over A. So since our B squared is 9, so it will be 2 9 over A. So 2 times 9 equals 18. Then our A is 5. So taking a half of 18, it would be 9. So 9 over 5. And approximately the value of 9 over 5 is 1.8. 1.8. So since the value of our B squared is 9, so it would be since the value of our B squared is 9, so it would be 2 times 9 over A, because our A is 5. So 2 times 9, it would be 18 over 5. So taking a half of 18, so it will be 9 over 5. 9 over 5. Approximately the value of 9 over 5 is 1.8. 1.8. So our latus rectum is 1.8. So now let us proceed to the endpoints of our latus rectum. Latus rectum by the given formula. Nakalimot ko. So let us proceed to our endpoints of latus rectum. So by the given formula, C B squared over A. So let us start to the quadrant 1. So our quadrant 1 will be 4, positive 4, 9 over 5. Then our quadrant 2 will be negative 4, 9 over 5. Then our quadrant 3 will be negative 4, negative 9 over 5. Then our quadrant 4 will be positive 4 and negative 9 over 5. So this is find our eccentricity by the given formula, C over E. It means our C is 4, then our A is 5, so 4 over 5, approximately it would be 0.8. So take note that our centricity is 0.8, so our ellipse tends to be elongated. So we are now in sketching the graph. So first we are going to locate our center, which is 0, 0. Then our focus 1 is 4, 0. Then our focus 2 will be negative. So we are now in sketching the graph. So first we are going to locate our center. So we are now in sketching the graph. So first we are going to locate our center, which is 0, 0. So it will be our center, 0, 0. Then our focus 1 will be positive 4, 0. So here. Then our focus 2 will be 0, negative 4. 0, negative 4. Then our vertex 1 will be positive 5, 0. I mean 0, 0, 5. So we're now in sketching the graph. So first we are going to locate our center, which is 0, 0. So here. Then our focus 1 will be positive 4, 0. So here. Then our focus 2 will be negative 4, 0. So here. Negative 4, 0. Then our vertex 1 will be positive 5, 0. So here. Positive 5, 0. Then our vertex 2 will be negative 5, 0. Here. And also we need to locate our end points of minor axis, which is 0, negative 3. So 0, negative 3 here. So 0, negative 3. Then here is 0, positive 3. So here 0, positive 3. So that is our end points of minor axis. And lastly, we need to locate our endpoints of latus rectum. So first, our latus rectum is 4, positive 4, 9 over 5. So here, 4, 9 over 5 is equivalent is 1.8. So probably here. Then quadrant 2, it is negative 4, 9 over 5. So it will be here. And now we are going to look at also the quadrant 2, which is negative 4, 9 over 5. So here, 1.8. So 4, negative 4, 9 over 5. So in quadrant 3, negative 4 and negative 9 over 5. So here. So negative 4, 9 over 5, it will be here. Then last, quadrant 4. And last, our quadrant 4. So our quadrant 4 here is positive 4, negative 5. So positive 4, negative 9 over 5. So it will be here, 1.8. 1.8, so 4, negative 9 over 5. Then we are going to connect our graph. So as we notice that our graph tends to be elongated because since our eccentricity is 1.8. So that would be the graph of the Greben problem, the equation of with passes at ellipse with the center at the origin, foci at positive negative 4, 0, and vertices at positive negative 5, 0. with the center of the origin 0, 0. So that would be our graph. And now we have our second problem, which is 4x squared plus y squared minus 16x plus 6y plus 21 equals 0. So the first thing that you are going to do is to combine like terms and move positive 21 into the right side. So it would be 4x squared minus 16x plus y squared plus 6y equals negative 21. Then, we need to factor out the 4x squared minus 16x. So it would be 4x squared minus 4x, then copy, plus y squared plus 6y equals negative 21. We take the perfect square trinomial and take 1/2 of square of the coefficient of x and y. So follow the rule. So it would be, since our coefficient of x is negative 4, then 1/2 squared, so it would be negative 4 over 2 squared, so it would be negative 2 squared. So negative 2 times negative 2 is equals to 4. Then same thing, ry is, since our coefficient of ry is positive 6, so 6 1/2, so it will be 6 over 2 squared, so it will be 3. So 3 times 3, it will be 9. Then we take the perfect square trinomial and take 1/2 of square of the coefficient of x and y. So follow the rule. So since our constant is negative 4, it will be negative 4 1/2 squared, so it will be negative 4 over 2, then squared, and it would be negative 2 squared equals 4. Then the same thing, our constant in y is 6. So it would be 6 1/2 squared, then it would be 6 over 2. So half of 6 is 3. So 3 times 3 equals 9. So it would be 4x squared minus 4x plus 4 plus y squared plus 6y plus 9, since 4 equals negative 21, then 4 times 4 would be positive 16, then 1 times 9 equals positive 9. Then take our first square binomial, so 4x minus 2 squared plus y plus 3 squared equals 4. Then divide both sides by 1/4. So it would be x minus 2 squared over 1 plus y plus 3 squared over 4 equals 1. So that would be our standard form. So our center will be C equals positive 2 and negative 3. So r e squared here is equal to 4 positive negative 2. Then rb squared here is 1, so it will be positive and negative 1. Now we need to find our endpoints of minor axis. Endpoints. minor axis by the given formula h plus minus b and k. So since our h here is 2, so 2 plus b, which is our b is 1, so it would be 3. So since an our k here is negative 3, then h minus b, so since our h is 2, so 2 minus b, which is our b is 1, so our point is positive 1 and negative 3. So that would be our endpoints of minor axis. And now let us proceed to the latus rectum. By the given formula, LR equals 2b squared over a. So 2, then our b squared here is 1, and our a here is 2. So 2 times 2 equals 2 over 2, then 2 divided by 2 equals 1, then taking a half of 1, it would be 1 half. So our latus rectum is, now we need also to find our endpoints of latus rectum by the given formula. By the given formula, h plus minus b squared over a and c. So first would be 3 squared negative 3 plus square root of 3. Then we have 3 over 2 negative 3 and negative square root of 3, and our also 5 halves. And lastly, we need to find the value of our focus and our vertex. So first, we're going to find the value of our focus with the given formula. F equal to h k plus minus c. So our focus 1 here will be 2 negative 3 positive square root of 3. That would be approximately 1.73. Then our focus 2 will be 2 0 and negative 3 plus zeros of 3. Then also we need to find our vertex. So by the given formula, it's equal to k plus minus a. So our vertex 1 here will be positive 2 and negative 1. Then our vertex 2 will be positive 2 and negative 4. And now let us proceed to the eccentricity. By the given formula, E is equal to C over A. So our C here is square root of 3 over A, which is our A here is 2. So square root of 3 over 2, it would be 0.86. So we are now in sketching the graph. So first, since our center here is positive 2 and negative 3, so it will be here. Then our vertex, which is positive 2, negative 1, so here. And vertex 2 will be positive 2 and negative 5 here. Then we need to find our endpoints of minor axis. So which is our endpoints of minor axis is 3, negative, positive 3 and negative 3 here. Then the second is positive 1 and negative 3. It would be here. Then let us proceed to the our foci, which is positive 2 and negative 3, positive square root of 3. So it would be here. So that would be our focus 1. Then our focus 2 will be positive 2 and negative 3, square root of negative 3. It would be here. Then our endpoints of latus rectum. So first, our endpoints of latus rectum is 3 halves and negative 3 square root, positive square root of 3. So it would be here. Then our secant is 5 halves. 5 halves then. To locate also our endpoints of latus rectum. So first we have 3 halves, negative 3 and positive square root of 3. So it would be here. Then secant is 3 halves. So 3 halves is negative 3 square root of negative 3. So it would be here. Then third is 5 halves and negative 3 positive square root of 3. So it would be here. Then our last endpoints of latus rectum will be 5 halves and negative 3 negative square root of 3. So here. So now we are going to connect the graph. We're going to connect the graph. So that would be our graph. So since our eccentricity is 0.86, which is 0.86 is closest to 1, so our ellipse tends to be elongated. So that would be the graph of our problem number 2. Thank you.